In today's lesson, we're focusing on the single most important skill in the field: how technicians diagnose HVAC systems. Anyone can hook up a gauge, but the master technician understands the why behind the numbers. To do that, we have to master two critical concepts: superheat and subcooling. Before we dive into the maths, let's look at our foundation: how refrigerant works. Think of refrigerant as a specialized delivery vehicle. Its only job is to pick heat in one place and drop it off in another place. It does this by constantly changing states, and this is what is done in the evaporator coil. Inside the evaporator coil, the refrigerant is cooled and enters as a liquid vapor mix. As warm indoor air blows over the coil, the refrigerant absorbs that heat and begins to boil, turning completely into a vapor. Once it's a vapor, it compresses and it's sent to the condenser. Here, it's much hotter than the outside air. It releases its heat to the outdoors and condenses back into a liquid. The refrigerant boils and condenses at very specific temperatures based on its pressure. Because we know these rules of physics, we can diagnose exactly what's happening inside a sealed system without ever opening the pipes. So let's take it from the top. Refrigerants constantly changes state from liquid to vapor and back again as it moves through the system. In the evaporator coil, it absorbs heat from the air and boils from a liquid into a vapor. In the condenser, it releases that heat outdoors and condenses from a vapor back into a liquid. Because refrigerant only boils and condenses at specific temperatures and pressures, we can diagnose system problems simply by comparing the actual temperature to the pressure. Let's try to understand what superheat means. Superheat is the temperature of the refrigerant vapor above its boiling point. Inside the evaporator, once all the liquid refrigerant has boiled off, the vapor continues picking up heat. The amount of heat added after it becomes a vapor is called superheat. We measure superheat to know if the evaporator is getting the right amount of refrigerant. For instance, low superheat means the coil is flooded, which means there is too much refrigerant, while the high superheat means the coil is starved, which means there is not enough refrigerant. Let's try to understand what subcooling is. Subcooling is actually the opposite. It is the temperature of the liquid refrigerant below its condensing points. In the condenser, once the vapor condenses into a liquid, that liquid continues to lose heat. This extra cooling is called subcooling. Low subcooling means you don't have enough liquid refrigerant, which points to a possible undercharge. High subcooling usually means refrigerant is backing up in the condenser, and this could be indicating a possible overcharge or a restriction. As technicians, superheat and subcooling tell you exactly what the refrigerant is doing inside the system. They help confirm whether the system is properly charged, whether the expansion device is working, or if the airflow issues are affecting performance. If you know both values, you can diagnose almost any refrigerant side problem without even opening a gauge or a pipe. We measure superheat at the evaporator outlets, specifically on the suction line, while we measure the subcooling at the condenser outlet, specifically in the liquid line. To calculate both, you have to compare these two things: the refrigerant saturation temperature, which is from your pressure gauge, or the actual pipe temperature, which is from your temperature probe. As a technician, these are the most important things you need to calculate: the refrigerant saturation temperature, which you get from the pressure gauges, or the actual pipe temperature from the temperature probe. The differences between these two numbers gives you your superheat or subcooling. Superheat and subcooling are simple but very powerful tools. Superheat tells you what's happening in the evaporator, while the subcooling tells you what's happening in the condenser. Together, they allow technicians to accurately diagnose system charge and metering device issues.